Welcome to InnoBuzz Java video tutorial part 12. This chapter we are going to study about input-output streams. We will study what a stream is, why we are using streams, how we can get input, and how can we write our data to output. Let us see the overview of the chapter. First, we are going to talk about understanding streams. Then we will see the purpose of input-output in BASIC. The input-output hierarchy of Java language. We will talk about the buffered streams and the reader and writer classes. Understanding streams. First, we need to clear up what a stream is. Stream is a sequence of data that represents an input source or an output destination. Stream is a model to our program. We don't know how it works internally, but it describes us where our data come from or where it is going to. The stream can represent many different kinds of data, for example files, devices, other programs, network sockets, memory arrays. Some just pass on data, others manipulate the data too. The classes of streams are in the java.io package. Let's see the classification of streams. We can speak about input stream and output stream. We are reading data from input or source stream and writing data to output or sink or destination source. Both is one item at a time. We can also make difference between byte and character streams. Byte streams are for binary data to perform input and output of 8 bytes. Character streams are for character values. Java uses Unicode conventions. That means this stream automatically translates to and from the local character set. The streams that only read or write to a specific location only contain this base functionality. The streams that only read or write to a specified location only contain this base functionality are called node or data sync streams. On the other hand, there are filter or processing streams which include more functionality, altering and managing data in the stream. They are layered onto node streams. We can make another difference using object-oriented perspective. This means we can separate the data and the object streams. The data stream supports binary input-output of primitive data types, while object stream supports input-output of objects that contains a mixture of primitives and objects. It works like the following. We use data input stream and data output stream classes for data streams, which implement either the data input interface or the data output interface. And the object input stream and object output stream classes implement object input and object output interfaces, which are subinterfaces of data input and data output. This means all primitive data input-output methods are also implemented in object stream classes, and that how we can imagine that object streams contain a mixture of primitive and object data types. We will meet other classes of java.io package soon. Let's talk about the input-output hierarchy in Java language. First, let's see the hierarchy of stream classes. The most important byte stream methods are in the input stream and output stream classes, which come from object class. The reader and the writer are also abstract classes and define the base of character stream methods. The first two are byte-oriented streams. They are intended for general-purpose input and output. The data may be primitive data types or raw bytes. The second two are character-oriented streams. They are intended for character data. Data is transformed from and to 16-bit Java car, which is used inside the programs, to the UTF format, which is used externally. The most important methods of these are the read and write methods for getting stream items, the mark and the reset methods, which are for positioning the streams, and the close method for closing the stream. We are going to see them in practice how they work. And there is also an important class in java.io, the file class. It is not a stream class, and this class represents actual files and directory path names. We are going to create file input stream, file output stream, file reader, and file writer objects with using the file class. Let's talk about the buffered streams now. Why do we need the buffered streams? Well, actually, for increasing efficiency. Let me talk about a little bit this in details. We have already mentioned that the streams either can write or read one item at a time. What does this mean exactly? For example, when we want to write a text into a file, our program sends a request to the operating system to make this operation. It isn't really efficient. Just imagine what happens when we want to write a large text into a file and lots of words are written one by one. It is expensive and it takes a long time. But we can imagine this situation with byte streams as well. What should we do? We can send them together. And there is also another problem that when our streams operation depends on a network activity or another action, it isn't effective to read and write at the same time. So this is why we need the buffered streams. The Java platform solves these problems with the buffered streams. But how do they work? Buffer streams read data from a memory space called buffer. And the native input API is called only when this memory space is empty. And backwards similarly. The buffered output streams write data to the buffer, and the native output API is called when this buffer is full. Let's see now the reader classes in details. These are subclasses of the reader abstract class. This is an abstract class for reading character streams. The first is the buffered reader. It has two constructors, which creates a buffering character input stream from the reader type stream, what is given in argument. One with default buffer size. The other constructor, we can set the size. The ready method tells us when the stream is ready to read. We have three read methods. One reads a single character, other reads characters into an array, and the last reads a line of the text. If the stream supports mark, which we can decide when with the marks supported method, we can mark our positions with the mark method. And if we call the reset method, it will take us to the most recent mark. The skip method is used for skipping characters. And when we finished, we can close the stream and release any system resources with the close method. The next one is the string reader. The constructor creates a character stream whose source is a string. The class uses the methods of the reader class. The next one is the char array reader. This class implements a character buffer that can be used as a character input stream. In the constructors, we can define the character array, what we want to use as a stream. The methods of the char array reader are the same of the reader class. The next one is input stream reader. It is a filter stream. It reads bytes from an input stream and decodes them to characters using a specified char set. The char set defines the mode how the bytes should transform to characters. We can use the default char set, or we can set one depending on the constructor. We can get the character encoding with calling the getEncoding method. There are also the close and the ready methods, which we have already learned. And we have two read methods for reading a single character or more character to an array. We will see them in more details in practice and also in browsing a little bit around the Java specification on oracle.com. Let's talk about the writer class now. The writer is an abstract class for writing character streams. Let's see the subclasses of the writer class as well. The buffered writer. This writes text to a character output stream with buffering character. The two constructors need a writer type stream that defines the character stream, and we can set the buffer size or use the default as we did with the buffered reader class. We can write out characters with three write methods. One is used for a single character, the other is for writing a char array, and the last is for writing a string. We can write a line separator with the new line method and flush the buffer with the flush method and close the stream with the close method. The next is string writer, a character stream that collects its output in a string buffer, which we can use for constructing a string. We can append and write characters to this writer by using the several write and append methods. We can flush and close too, and we can get the buffer as a string buffer with the getBuffer method, and as a string with the toString method. The char array writer. This class implements a character buffer that can be used as a writer. There are the same methods as in the string writer, plus size and the write to method. Size is for getting the size of the buffer, and write to is for writing the buffer into another character stream. Let's talk about the output stream writer. It is the pair of input stream reader. It is used for transforming characters to bytes. There we use write methods to writing characters or strings. Print writer. This stream contains methods for representing objects to a text output stream. As I've promised, we come here to the oracle.com and look around a little bit, browse around a little bit in the Java platform API specification. This time we are going to see some input-output things, classes that are inside the input-output package. This is the input-output package. We can see here. I go inside. This package provides for system input and output through data streams, serialization, and the file system. Well, we have lots of things here. Lots of interfaces that are inside of this package, and of course lots of classes. Some of them I've already mentioned in the slides. We are going to go inside them, and there are a few exceptions that will happen to us when we use input-output. In fact, the exception handling is very important when we use the input-output package, because this is the place where exceptions will really happen to us very frequently. This is the input-output exception, the most common type of exception here, but we can have also write aborted exception, and of course the file not found exception. It is very common. Interrupted input-output exception, and so on and so on. So these can happen to us, and these will happen to us. And also there is an error, input-output error, when a serious error has occurred. So we have to handle them always. We have talked about the classes, that some of them are byte-oriented, and the most important are the input stream and output stream. Well, these are here, of course, the output stream and the input stream. Well, let's go inside the output stream this way. This is an abstract class, and this is a superclass of all classes representing an output stream of bytes. Well, the most common methods are here. You just close write and things like that, flush. We will use them in the practical part, especially the file output stream. Here, yes. Okay, these are the subclasses, of course, and there are the file output stream. This is what we are going to use. This is an output stream for writing data to file or to a file descriptor. It has many constructors. We are going to use the string name in the practical part, and we are going to write to it. We can write just simply 1 byte, but we will use the byte array. You will see it. And of course, there's also the input stream. This is the same thing for input. These are the subclasses of it. Byte array input stream, file input stream. We are going to use that, and of course string buffer input stream. But these are still byte oriented things. The other big part is the reader and writer. These are here, abstract class for reading character streams. So this is for the character streams, as we have told. And inside this, there's the buffered reader that we were talking about, the string reader, also the char array reader, and the input stream reader. And the methods, the most common methods, the reads, of course. This we read the characters into an array, or just a single character, or a portion of array, many reads. And we can mark the present position in the stream, for example. And of course, we will always use the close. It is important because there is amount of memory that it uses, and if we open lots of files and use lots of streams, then and read and write them, we can have big amount of memory that that will be allocated for it. So we always have to close them. Of course, there is the writer as well. This is the same thing for writing. We have also talked about the file, and this is what I want to show, that inside the class file we can see, and we can see lots of information. This is an abstract representation of a file and directory path name. So when we create a file, the constructor, we give the path name, for example, and we can use the parent and child strings as well. You can read this over. There is lots of useful information here. Of course, we don't have time to look over it. And lots of methods that can be used on a file. Get parent, get name, and so on and so on. So length, list, lots of things we can we can create also files with URL. So the file we are going to also use in our practice when we are creating files. So these are the most common things. And we have also talked about the buffered reader, buffered writer, which belong to the reader and writer. And this is the parent is the reader. We are not going to have it in the practice, so I came in this way. It reads text from character input stream, and the specialty is that it puts in the buffer, basically because it's more efficient sometimes. We have talked that it has two constructors. The first uses a default size, the second uses a specified size. And there are three different read methods. We can read the whole line and some characters into a portion of array or a single character. So we can use it just like without buffering. The difference is the efficiency mostly. And we have also seen that inside the reader we have the string reader that we were talking about, and the input stream reader, char array reader, for example the string reader. This is the source is always a string here. So there are lots of different classes inside the input-output class, and what I say again is it's worth the time to look around because they are all a little bit different, and the usage of them is also can be different. And whenever we create a program, we have to choose the right class and the right way to read or write our programs, if they are character or byte oriented. So, or if we want to use a buffer, for example. So this is something that we have to clarify. There are lots of things here, and it is the best to know a few of them because we cannot show all of them in the practice. Let us now see the input-output streams in practice. I started an empty project again, and we are going to create some classes to be able to show the input-output streams and how they work. I'm going to create a new class here in our project, which is going to be file tester. File tester.java. And in this, we are going to create a new file, a new txt file, and write some data in it and just save it. And also we are going to read the data back from it. The whole thing is going to be in a try-catch block because it can very easily lead us to an exception. So I write what I need is to import the Java dot to import Java dot io star, and I'm going to create a print writer object. With this we are going to be able to write our file, to create it, and what it needs in argument is a file writer. So I instantiate the file writer, file writer class, and I give a name. Well, the name is going to be given in the constructor. So public file tester, and we get a string here, file name, okay, what I'm going to do is to use this. This is going to be a field of it. So I get the file name, and the file name is going to be file name under slash. So I'm going to create a file tester, and I'm going to give the name. Okay, and well, let's write a public void um, create file and put everything in there. This is going to be the create file part. Okay, I'm writing the catch because it gives the error. Well, it's an EO exception that we can generally catch here. So I simply write e dot print stack trace. Okay, and what I'm going to do here is create a new file writer, as I mentioned, with file name. That's it. Yes, and then we just simply print some things in it. As you can see, there are lots of prints and print lines and things like that. So I just write a few of them. Just some text, and some stuff in it. Maybe I can also add the float here, and in the next I'm going to give an integer, for example, an integer object, just to show that I can use different things here, and anything like that. Stuff like that. So I can put different things in it just for testing. And what I'm going to do is writer.close at the end. That's it. That's all we have to do if we want to create a new file with some things inside it. And of course, this is also not very complicated to read things. I read read file. Now this is a special method which we're going to use for our string name. So this is only working in this class, and I'm using a file reader here, file reader object. This is going to be a new file reader. I get the file name, and yes, of course, I still have to use this try catch just like I did. Okay, so we should put it in try catch as well, and just a simple while cycle to read some things. Reader dot ready. So while it's ready, we are going to use it to get the characters from it. I'm going to read the characters out of it. Reader.read. This gives us an integer, but this is going to be a character that we want. So I simply typecast it to car. That's it. And we just write it out. Just every character of the file. That's it. And I close it. So if we have this type file tester object, I can create a file like this, and I can read a file like this. To try it out, I just what I have to do here is create a file tester. App tester. This is going to be a new file tester, and I give a name here like test.txt. What I need is to give the directory like dot and slash, because it's from the root here. So I want to create it here in our project, and just let it test, let it work. Yeah. App tester dot create file. Okay. Let's see what it is doing. Okay. There's a test.txt. As we can see, I can bring it here and see what's in there. The things are in there what I put here, so it's all right. You already have it. And if I want to read it with our program, just read file. I save it and I run it. Well, you can see that it is here, but everything is in one different line. Yeah, because I use the system out print line here that I should have used just simply print, because this way we are using characters. Okay, I save it like this and I run it. That is more like it. Okay, this is cool. It's working as we expected. What we are going to create is a different thing. We are going to, in this we have used the print writer and the file reader classes, file writer classes to create and read the files. But in the next one we are going to use different things. This is going to be a class that is going to tell if the two files are equal to each other or not. This is going to be content equals class, and well, in here we are also going to create a new constructor. Well, let's make it static, because it's not going to work on objects or instances. This is just a static. It's good for us. And content equals, and what we will have here is two arguments, the file1, so file1, and another file object, which is the file2. Okay, so we get two files, and okay, what we are going to do is inside here is create two input streams. Input stream in1 and initialize it to null. Input stream I didn't use the import, that's why I get the error. Okay, so an input stream and also another one, both of them is initialized to null, and what I will use is also a try catch block here, and I catch the same things here, EU exception, so best is to copy. Okay, all right. Okay, we are going to create the in1 is going to be a new file well, I copy it, so I won't it's going to be a file input stream, so a new file input stream. A new file input stream with the file 1. Okay. The same thing with the second. So in 2 is going to be same thing with file 2. So we have got 2 file input streams here, and we are going to check if they are equal to each other. In what way? Well, I just used two integers, like something like b1 and b2, and we will use a cycle here, the while cycle. Well, this is going to be reading the files. So b1 in each loop cycle is going to get the value that is in one.read. So we read one character here, and if this is equals to b2, which is the same thing in the second, so we just compare what's on the same index, on the same place in the files, going byte by byte, and if they are equaling, then we are going to continue. And also we will have to check if we have reached the end of the file. So if b1 is not equals to -1, because the end of the file is, so when we reach the end of the file, then the read gives us back here -1, and it's in b1. So here we can check the b1 and also the b2 not equals to -1, because if they are the length is different, then some of them can reach earlier the end of file than the other, and that's it. Well, we can also simply write out something, write out the characters or something. It's not, so I write at b1 just with a simple print, typecast it. Okay, so in every cycle I write it out just to see what is there. Okay, and at the end of it, when for some reason we quitted the cycle, the reasons can be that b1 is not equal to b2, or one of them is -1. So anyway, if b1 is not equal to b2, this is going to mean that the two files are different. Because if we go through the whole file and everything was the same, then we will reach -1 both, so they are going to be equal. In any other cases, they are not going to be equal. That is very simple. So we can simply return false in this case. And in any other cases we can return true. This is it. I still want to write a finally here, because it is also important to close our input streams. So we are going to close them, but it is also have to be in a try-catch block, just like this, because it can happen that we couldn't even open it. So we have to be very careful with these file input-output things. So the input-output is one of the most dangerous things. So it can throw exceptions very easily. So this is the place where we really have to use the exception handling. So I test if in1 not equals to null, because it was started with a null. And if it's not equal to null, then I can close it. That's it. And I can catch your exception here as well, just like this, and do the same thing with the second one. So this is the way we close it in a safe way. That's it. So we close them. Let's look it over. We have got two files in arguments. We use two input streams that are new files in file input streams with the file names, the file objects created by the file objects as an argument. And we go through them. And if everything is all right, every byte is the same, every character is the same inside the file, then we go through the while, and in this if we won't return false, because they are going to be -1, so they are going to equal here as well. And in that case we return true. In any other cases, if they are not doesn't have the same length, or something is different here inside them, the content, we return false. This is a simple way. I save it, and to be able to test it, I'm going to create another file which is called test2.txt here first. Yeah, we have got test.txt and test2.txt, and in fact they are the same things, the same files here. So I comment this out. We don't need this right now. And to be able to test this content equals Java, we are going to write out that just write out the boolean that was given here. Yeah. So we need to use the content equals content equals with the parameters. Well, it is going to be a new file here. A new file. One of them is going to be the ./test.txt, and the other is going to be this text2. Test2. And of course I still need to import the java.io here. Yes. Content equals dot content equal or something. Yes. I also have to use the name of the class. Yes. Okay. That's it. Well, this is not the best that it has the same name. At least I should write it with a small c, because this is just a simple method. Okay. That's it. Okay. So here we have got these two txts, and I'm going to write out what it gives us back. Let's see. I save it and I run it. Yes. There's the text inside that I've written, and it gave us true because these two files are the same things. They are the same. To be able to test the other way, well, I just write something here to modify it a little bit, and I'm going to create the test2.txt again. And we are going to, well, let's make a test3 one here. And this time test for this one. So we have three different txts here, and we can test it. Well, I don't have to do this. Okay. Yes. As you can see, we got text false. So the result is false, and the text here is actually it started to write out the things that were the same, but they are just same in the four first characters. After it came something different, the twos between the two files. So after that it stopped and returned false. So this was the only part that was the same. Now that's it. This is how it works. Let's do something else again. I'm going to write a class to be able to copy files. So this time we could equal the content. We could check if that content was equal here. We use input streams and file input streams, and we use file objects. So we have used the read method to read from the files, and we opened and closed the file input streams. What we are going to use now is also the file output stream. So to be able to show this, I'm creating a new class. And this is going to be the copy file class. And just before I forget it again, I copy the import. Okay. What we will need to write here, I want to write here, is a static method that is going to copy our file in a safe way. Let's call it copy safe. We will get a string here, which is the file name. Okay. What we use here is two strings. One of them is going to be the source, and the other is the destination. And source is going to equal to file name, and also going to be the destination here. Okay. I want to create a new file, so I want to use the name of the file that we received here. So, but of course change a little bit. So I get the index of the source, that last index of the, so I want to get the last index of dot, because I want to have the name without the extension. So this is going to be the index of the last dot in the name. And now I can create the destination, which is going to be the source, that's substring, from 0 to index. And of course, I also add the dot here. And what I will just simply add is this sign, for example. I don't know the name, actually. And also the parts that are after it. So the ending also. So this is index plus 1. So this is the substring from index plus 1 until the end. So this is the substring with these arguments. So we have the same name, we will have the same destination, we have the same name, but adding this character. Okay. I'm going to create a file input stream a file input stream, which is in, initialize it to null, and a file output, which is out. The file output stream, which is also null. And we are going to have our try-catch block, just as in the others. Okay. And inside the block, I'm going to use the in and the out as well. And I instantiate file input stream, its source, and the output stream with the destination. This is going to be the destination. So I have got two input stream, an input stream and an output stream. And what we use is a byte array. Byte array here. So it is an array reading that I will use. And it's going to be a new byte array. And the length of it is going to be in dot available. Now this is, I deleted, and we can see it here. So it returns an estimate number of the remaining bytes that can be read from this input stream. So this is going to give us the length. In other words, and we only have to write in dot read, and we are going to use this, the byte array, and of course with array, and that's it. And we are going to write the same thing out in the out. So we read everything from in, which was the file that I gave here, and write it out to the other file, which is the destination file, which is the same, has the same name, differing only with one character. I write it out here, and that's it. That's the whole thing, what I need. And actually, I also want to close them. So I use a final block, which is very similar to this, because I want to, yes, I want to write the safe code, so I close both of them. That's it. I save it. So if I give name to it, it will copy. Well, let's try this out. We have already got some files here. And what I'm going to do is write copy file dot copy save and give a name to it. For example, let's test3.txt. Let's see how it is working. I want to copy this. Yeah, we can see that we have test3.txt, another one with this extra character. Just to have a look at it. Yeah, it's got these things that we put in here when we created it with our Java. So this is these examples show some using of input-output things. The file input stream, file output stream. We used files and mostly everything that I mentioned in the PowerPoints. The important thing is that I always have to handle the exceptions